continuous supply to the to keep the internal R not coil as on, and this at this same time will continuously keep the Y not on. Okay, external outputs coil. Yeah, yeah. To distinguish internal output from external relay, they are given in different types of address. So the FP controller uses X for external, R for, just now I mentioned already, X for external, R for internal. So X not notation is used for contact. The value of the switch resistor and input 0 is stored in address X0. Okay. So different input, let's say we have more than one input, then we have X1, X2, X3, all that for the external relay. Same similarly for R, internal relay, we have that. Okay, now coming back to internal relay. Now, the internal relay is presented by the symbol of for using the symbol for output device with the address. The address notation indicates the internal relay. So here, this is internal relay contact. Okay, or not. So the switching contacts are designed with the symbol of input device and given the same address as the relay output. So here, if here is used R naught, the internet relay, the internal contacts also given as R naught. Okay, same name, just to so that you can easily refer that as your reference. Your reference can now can now you can just turn on whenever the internal coils turns on, the contacts will turn on. Okay, now I mentioned that earlier. Now here, internal relays do not provide external outputs. Uh, they can only be used within PLC. That's a reason why we use internal relay. They can only turn within the PLC. You cannot go outside. Like external relay, you can go from outside. You can turn on in what's inside, and then from inside, you can turn on what's outside. That is external relays. Okay, so they designed for external only purpose only. Now for internal relay, it starts with the address of R9000 called special internal relays. Okay, these are special. They are no more, they're not R not, they are R9000. These relays have specific application and are used only for contacts, not for out. So see, and it can be also used for error detection, operation status indication, on off control relays for specific condition. Okay, let's do some operation using external and internal relay. Now, in this case, we have multiple input condition. So this is see, this in one, in two, and in three. They are contacts or sensors or switches that when we switch on, is going to turn on your internal relay one, IR1, is energized. That means turn on. When this turns on, it is going to turn on IR1, this contact, and then depending on what's the internal this info is activated, then there's output and out one. Okay, so it is very control based. That means we have many steps of control to ensure the output is given. So that you have to satisfy all these conditions. The condition is that input one is turned on, input one is turned on, then input two is already short. That means already turned on. Okay, this sign symbol here is already like it is having a contact. Okay, it's already having a contact. Okay, so into a so that will turn on IR1, and IR1 will turn on this contact this contact. Okay, and then you waiting for info to be turned on so that output can be given out. Okay, so let's say such a control could be used in automatic lifting of a barrier when someone approaches from either side of the barrier. So you know what's barrier? Let's say a car is going past a barrier. So you're driving the car through a car park, and then there's a barrier. So you wait. What you show you show your card or you pay some money. All this. So the many controller. So one out may be used to drive the motor to lift the barrier. Okay, out one is used barrier. But what about other things? It's like your card, showing your card, or you're making some payment, or you pick up a card, and then you see the presence of car must be detected, and then the card must be taken out. Okay, these are the two things that will cause the will trigger the barrier to be opened after. Okay, so So here in 1, in 3 is the sensors. I mentioned just now vaguely that sensors, yeah, their contacts, but your contact will turn on based on the what it sends. So sensors are placed on both sides of barrier to detect the presence of a person. Okay, since this barrier can open either side. This is not like a single way barrier. These are two-way battery barrier. So this two-way barrier, so it needs two sensors on either side of the barrier. So we use in 1 and in 3. Okay, either one is on, it can override the other one. So if you have one person coming the other side and nobody in the opposite side, you still will turn on because this is the condition set in the PLC. You see, when I1 can, if I1 is on, it will override I3. I3 is IN3 is on, it will override I1. So either way, it will turn on the IR1. Okay, can the internal relay. So in2 is used as shutdown. That means I continuously make it as a short circuit. That means it is just used to shut down the barrier operation if there is some problem. Okay. Now in4 detects the position of the barrier. Okay, whether it's open or closed. In this case, it will detect whether the is a sensor. It's an in4 is a sensor. The sensor is detecting whether the barrier is already open or not open. Okay, if it is not open, it's not open. I mean, it will be. Uh, so we have a condition here. Once the IR1 is turned on, IR1 here. So naturally your output, you should give output lah. Okay, that means the barrier must be open. But the IN4 is now blocking it. Okay, IN4 is blocking it. Now how to design this? Okay, let's do this. So if let's say there is a person coming, because the current position of the IN4 seems to be like a bit, it seems like it's not going to allow, even though there's somebody is coming, going to go through the barrier. Okay, the IN4 is still contactless, like there's no contact. Okay, so now in this case, what should be the position of X4? X4 is the detecting whether the barrier is open or closed. When the barrier is closed, what should be the position of X4 when the barrier is closed? So here it should be it should be closed, isn't it? It should be closed. Okay, so here so it's closed lah. So that when you turn on X1, and there is a person who are waiting in the location at one side of the barrier. What happens? It will turn on the R0 will turn on this contact R0, and then that will this X4 is a sensor that sends the barrier to be closed. So it's closed. So because it's closed, what happened now? Why not will now a motor that will trigger the system to open the barrier. Okay, when it's open the barrier, what will happen to X4? X4 will close. That means it will remain closed, will remain open because now there's no supply. Okay, once it's supply, that means it has no supply. That means once it's open that it is just allowing the person to go. Okay, can I? So when it's open, it's this X4 becomes open circuit, like an open circuit. Okay, now next, what happens? How to close it? The mechanism here seems to be working only when it's open. What about closing it? Okay, so why not must become what? Once this open, why not become off? When the why not off, what happen? Why not off? We should trigger something else, isn't it? So we have probably we have to redesign this, okay? So that if why not is open already, after some time a timer or what or another sensor, when the person has crossed the barrier, it should be triggered to close. Okay, can I? As long as the X1 and X3 doesn't detect any more people coming through, I mean near the barrier. Okay, now this is another example where we are resetting a latch. Okay, now here we have a heater coil. We want to heat up something. Okay, probably a chemical plant or what. So a holding or latching circuit always energizes its coil through its own contact as shown below. Okay, So what happens here is that when I give a contact, when you press the start, what happen? Or C1 contact, okay, whichever, because contact C1 can be a sensor, okay, so it can short circuit, or it can short circuit means it can turn on the contactor coil C1, and this contactor coil C1 will now make the contact C1 at this bottom. This is relay. This relay should turn on the contact C1 2 and contact C1 here. These two, okay, can these two will be turned on. Why these two will be turned on? Now the first one is once you press the button, it's only a push button. You push one time. After that, turn on contact C1. Once contact C1 is turned on, then is to have a continuous supply of voltage to the contactors coil C1. We need to make sure that the push button, once you push one time, then it goes up again. It becomes open circuit again. So to continue supply voltage, so we have the contact C1. Okay, contact C1, and this contact C1 will turn on also the contact C1 2, which is the rung at the lower rung which connects the supply to the heater coil. Okay, and then in between the contact C1 and the heater coil is the temperature high sensor. The moment the temperature high switch, temperature is too high, then this sensor temperature high switch will turn off, so that there's no supply of current to the heater coil. Otherwise, the heater will still supply the heat to the system if the temperature has reached certain threshold, very high value. Okay, we just want a precaution step, have a precaution step to prevent the temperature from going too high. Okay, so when the temperature reaches a high limit, the temperature switch open, the power supply to the heater is cut off, but the coil remains energized unless the stop button is pressed. Now here, okay, the power supply to the heater is cut off. Okay, but the coil remains energized unless what is the coil? Don't get wrong. That means temperature, this one turn off already. That means it's open circuit, no more current going there. This contact still on. This contact is still on, because at this point, what happens is that now what happens is that we must be careful, because now the temperature high switch only is turned off, or it becomes contactless. Now here, if the temperature drop again, let's say temperature, because heater now switch off, temperature will drop again. There is a possibility that when temperature drop, the heat, the contact, the temperature high switch can become contacted again, becomes short circuit again, which supplies the supply voltage to the heater coil. Okay, okay, now, so we have when temperature reaches high limit, the temperature switch open, so we have to press the coil, but coil still remains as on unless the stop button is pressed. Okay, now, so when you implemented PLC, an internal relay contact should be used to replace the stop button. Okay, so what happens here is that I rather using internal relay. So what happens here is that instead of a sensor, I just use a internal relay. So here, what happens is that the output of the heater, why not, will be turned on by the why not. This is output of the heater. So we have internal relay coil. Okay, don't get mistaken. This one is output to the heater. This why not? This is the output. We call it output relay. Okay, X naught is the input. Sorry, is the sorry, we don't call it output relay. We call it external relay. Why not external relay? X naught is internal relay. Okay, internal relay. Sorry, external relay. And then why not? This why not? Output to the heater will turn on this continuously. This why not? So this internal relay why not will turn on the sorry, X naught. Sorry, I'm wrong again. X naught and Y naught are referring to the internal relay. Am I right? Is it internal relay? Only R naught is the external relay. Is it? NC internal relay contact. See, look back at the R term. What is the R and the X already? So R is, sorry, R seems to be the internal relay. R is the internal relay, whereas the external relay is the X. Okay, X. Is it X or what? Wait. R is the internal relay, and then the X is external. Sorry, X is external. R is the internal. Sorry, I'm wrong. Okay, so now what happens here is that Okay, what happens here is that okay, at this point, so we replace the internal the switch button, the stop button with the internal relay contact. So what happens here is that uh, as I told you, the R is internal relay contact. This is what stop button is supposed to be. Okay, the other this one, and my cursor. So now here R not is supposed to be the stop button. Now it is replaced with the no contact internal relay we call it NC internal relay contact. So here what happens when the when X naught is turned on, the switch sensors are turned on, R naught is already on. So what happens here is that output to the heater is triggered. Okay, where output to the heater will continuously allow Y naught to be turned on. Okay, the sensor. This will continue supply until output to the heater is turned on. Okay, can I? Now, now, what happens here is that the moment output the heater is turned on, we have the heater heating up. Okay, but then the temperature high switch will only turn on when the temperature of the heater becomes too high. Okay, that is a sensor X1. Okay, that will only switch to on when there is a too much of high heat or too much of temperature goes too high. Okay, that will trigger the internal relay called R0. Okay, and that will what the internal relay driver now make this one turn off. Okay, up here. Okay, here what changes should be made to temperature high switch. So here you should close when temperature is high. Okay, you should close when temperature is high. Why it should be closed? Because that should turn on the internal relay coil R0. This one will turn off this and no contact internal relay coil. So what happened when external temperature limit is reached, external contact X1 closes, internal relay coil R0 will energize, okay, and that will what? So when internal relay coil energizes, NC internal relay contact R, I mentioned to you, NC internal relay are not will open. This no more this line here, cross line here, okay, and then will cause the Y not to de-energize because no more supply, okay. So when internal relay coil R1 R0 is internal relay contact R1 opens, external relay Y not de-energizes and no more heating. That okay, no more heating. So when the external relay Y not de-energizes, output power to the heater is cut off, external input contact Y not opens. Okay. Okay. Now when external relay and Y not de-energizes, output power to the heater is cut off. Okay. This one is cut off. Output power to the heaters output power to the heaters cut off, external input Y not also cut off. Okay, this is all cut off. Okay, can I hope you can get it. Okay, because X naught is already cut off earlier itself, because that is just a turn on okay, to turn on uh, because we have continuously Y not turn on, so X naught is turned off earlier itself. Okay, now so now next what happens when temperature okay, when the external output contact Y not opens, the holding of or latching of circuit is said to be reset. Okay, so here what happens next is when external input contact Y not opens. Okay, so what happens? The holding or latching circuit is said to be reset. So we reset. That means system is off. Okay. Now, when temperature is low, external input contact X1 opens. Temperature, that means it's not open lah, because this sensor, when temperature become low, this is open. Okay, that will cause the internal relay R1 to de-energize. Okay, and now we start over again. To turn on. Okay. Okay, when temperature is low, so when external contact X1 opens, internal relay R1 DHA ready for the next cycle. So what happens next? If in the previous control circuit another internal relay is used for the start button, we have set reset. We have a set reset operation. Okay, so we can have a set reset operation. We can turn on the again the set so that we do this R0 is to turn on what? To turn on this signal again. Okay, so this is set to set. There's now only reset is available. Okay, so we have another internal relay is used here. Another R not. We have a set reset to create the set reset operation. Okay, so what happens here is that we have this operation. So what happens here is that when you have this R0 and we set it on, what happens? R0 turn on. This R0 will turn on this switch here, and this will trigger the it energizes the Y0. And when Y0 energizes, what happens? It supply the voltage to the or turn on the motor or the heater in this case. Okay, so it will turn on the heater, and then when the temperature goes too high, X1 is turned on, X1 is turned on, and X1 turned on, R1 will turn on, R1 will energize. R1 energizes, this R1 up here will now what do you call it will switch off. Okay, they'll become contactless. So this contactless, then why not become off again? Okay, so when Y not off, what happens? Y not off, what happens? No more supply to the system. Then we wait for that because both these are not Y not now becomes contactless. Now this will start again if you press the set button again. Okay, only that can do. Now here, the moment R not is off, this R not so off earlier. Okay, now so now, so in the FP1 C14 controller, the set reset operation is performed like this. Okay, so this is how we do set reset. So X0 open, X0 is sorry close. Will set the Y0, turn on the Y0, and the Y0 will call and then X1. You want to reset, you press X1. You want to set, you press X0. Okay. Okay. In this case, okay, whenever set is pressed, the Y0 turns on, and then in reset is pressed, Y0 becomes turn on. Okay. So there is something called master control relay. So it's sometimes necessary for whole section of ladder diagram to be turned on or off when certain conditions are satisfied. One way of doing this is to use the contact of same internal relay in the specific area. An alternative way is to use master control relay. So how to do that? Okay, now here this diagram shows illustration. It describes the master control relay when in one sensor, in one is a sensor is off. What happens? The ventral relay output MC1 is off and its contact is open. Okay, MC1 is off and its contact is open. All other rungs between MC1 and MCR1 also, because MCR1 are also disabled because of the location of the MC1 is here. Is series. It is in series with the other rung. So out1 and out2 cannot be switched on and on by in2 and in3. Okay, even though in2, in3 detect or it becomes on, no use because it has to wait for MC1 to turn on. Okay, so it really depends. The master one is in one behaves like a master. Without it turn on, the whole system is down. Okay, so the program is executed from MC0. In this case, this instruction to the MCEO or 0, sorry, instruction when X0 is turned on. Okay, so X0 is turned on, MC on turn on. Okay, what happens next? So next is okay. Okay, so the program executes the same way as the program below. Okay, now the program I use a number of master control relays. Okay, so there can be many combinations as well, like this. Okay, to enable various sections of ladder to switch on or switch off. Okay. Then there's also jump. In a jump operation, if a specific condition are met, a jump relay enables part of the ladder program to be jump over in. So if in1 is closed, there's an output at the jump relay. So the program then jumps to the rung where jump and occurs. So for example, in FP1, okay, the jump instruction is JP and the end of the jump is indicated by LDL. Okay, so JP causes all instruction. This overrides lah. It overrides the between sensors. If one sensor is given far more important than others. For example, a warning sign. It can be also like temperature just now. When some temperature is reached, it quickly jumps override all the other sensors to off the system or something like that. Okay. Can I? So jump within a jump. Okay. We got nested jump. Okay. So we can jump the condition for JPO. In this case, JPO is met, then the program jumps to rung 7, skipping rung 2, 3, 4, 5, 6. If condition for JP1 is realized, then JP1 is here, then the program jumps to rung 4, skipping only rung 4. So all this is possible. Okay, can I? So I will stop here for the lecture today. PLC only very less coverage, but you have 2 questions in the final exam. And another 2 questions is from the optimal control side. Okay, PLC questions are quite straightforward. You just have to look at the past year questions and probably something similar will come up. Okay, but not for optimal controller. You cannot just look at the past year question. You have to be very good in this understanding the optimal control. Then you can answer. Okay. Okay. Now coming back to our assignment work. If you have any question, please let me know now. Hello, anybody have the assignment question? Now, some of you have sent your copy of your assignment to me. Some have met me personally, and I've done some correction to the code. But what I realized, most of you came to me through either physically or through email or through WhatsApp. Seems like giving me some ChatGPT's AMPL code. Okay, this ChatGPT AMPL code will not work. Just follow the code that I've given you. Okay, and you need to just follow what I have done earlier. I showed you example. Follow that, write your code in AMPL. Then I can help you. It's easier for me if there's any problem, because when I look at the solution you give in AMPL, it seems like really off, like all the position all change, so it becomes very difficult for me to interpret the problem. Okay, and most of you seems to be having no clueless about AMPL, even though AMPL is such an easy program. It is not a programming language in the sense that it doesn't have if else. It doesn't have yes, it has if else, but not all of you need to use it. Some of you have to use it because of the type of the paper that you have selected is such that you require to use if else. Otherwise, there's no for loop, there's no while loop. Okay, or seems to be very straightforward programming tool for implementing optimal control. Okay, that's the easiest I can find so far. Okay, among all the programming language for implementing optimal control. Okay, and it's free. Okay, so I hope that you use it in the right way, like the example I've given you. Okay, now can anybody have any problem? Please let me know in the model. Please let me know now. Anybody?
Yes, sir.
Tell me.
Maybe can you?
Can you share?
I cannot share.
Oh, okay.
I don't have permission to share screen.
Yeah. How to share? I can't go to the. What's your name?
Hong Li, Lee Hong Li.
Okay, I must give you permission to make a presenter. Okay. Okay, now. Okay, I made you presenter already. Okay, open your file. You don't.
Yes.
Okay, can you? Okay, you showing me the code, ah? Oh, okay, 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 yeah.
So basically I have tried to plot it up, but I'm not sure whether will this value correct or not. Because
Okay,
in the
this is what? Okay, okay. What you do? You have how many parameters here? How many variables here?
six six
SE. This is SEIR model or SER model. What model is it? They are different in the disease control. There are so many models. Huh? We call it SER model. Okay, look at it. SEIR. Okay, this is the SEIR lah. Or is it more expanded than that lah? Okay, S stands for susceptible population, E for exposed population, I for infected population. What is TV? V is vaccinated population, is it? R is recovered population. T is what? What is T?
is
Okay,
treated person
treated
which
means not
recover
vaccinated lah. Not
uh,
vaccinated, isn't it? Okay. Okay then. Now you go to your how many input controls are here?
only three
Vaccinated and treated. Is it? No.
input control U1. Wait, let me see. U1
Can
is
you
for
expand it?
the
I can't see properly. Can you expand it?
oh
I
okay.
mean, make it larger. Okay, there is U. How many U's are there? U1, U2, U3. My God, we got three inputs. Okay, this one is asking for trouble. Okay, okay. Now you are okay. C1 is sorry, U1 is education. U2 is
Two vaccination
vaccination. U3 is uh,
surveillance.
surveillance measure of ability of medical welfare to diagnose and treat people. Okay, now what is your U1, U2, U3 results? Show me in your AMPL simulation. What do you?
Because you listed got two cases, right? One is stop without constraint, and
Oh,
then
okay,
one is currently I'm doing now
okay,
case one, so without
okay, okay.
constraint. So I didn't set. I just use the
Yeah,
value
it
as
doesn't matter. Doesn't matter. I want to see U1, U2, U3. What's the result?
oh,
U1 is input, nothing to do with the constraint.
uh,
Did you plot? No,
yes,
you showed
I
some.
did.
Uh,
You only want to control, is it?
yeah.
It becomes like this.
Okay. Like this is the last point. Like U1 is supposed to be the education, is it? Why would we educate at the last point? Does it make sense? We want to educate the initial state as well. Okay, go to the next one. U2 it's like completely vaccination only. Okay, go to the next one.
Three.
Or it doesn't want to educate at all. It only wants U1, U2, and U3 completely. So that makes sense for U1. Why it doesn't? Okay, maybe the cost. Okay, now you go back to your code. Sorry, your paper just now you showed. Okay, what do you use for the weightage? For C1, C2, C3.
Oh, uh,
C1, C2, C3 is the weightage for the inputs respectively. Did you use or okay zero all the equal weightage?
0.5.
Okay, equal. And
Because
what about
I only make hypothesis. Because in the text it doesn't give
okay
the
the
direction value
okay
what
what is
value
the
should I
out?
use.
What's the paper's result? Paper use
Its
U1
result
square
is here
U2. Okay,
0, 0, 0.
wait up. What is rate? Wait rate. Okay, different simulation lah. U1 U2
I
is not
think it's also doing like with constraint and no constraint.
okay. Okay. Wait, this is no, they didn't have a U1, U2, U3 results. This is not the U1, U2, U3 result. This is U1 is 0, U2 is 0, U3 is 0. No input. Oh, green is with the input. But they didn't tell what's the actual value of the U1 and U2. Okay, green is with input. Of course, infection will be lower because of the U1, U2. Now no more 0. But now recovered population seems to be. But see, the problem is that okay, didn't The paper never show the results, huh? For only U1, U2, U3. No, huh?
Yeah.
No, this is just like that, lah. They didn't say what is the value of U1, U2, U3. Okay, go up, some more. That's all, is it?
Uh,
Okay. Okay. Um,
then the above one is the theory part, like how they get equation.
yeah, that one's okay. Now, okay, seems like okay. Okay, can you show me your what sustainable, recovered, exposed, all these results?
Oh, yes. This one is
Uh,
susceptible.
okay. So the population size is the 1,000, is it initially?
I said 1000. Yes.
Okay, you said based on the paper, or you said you choose the number.
I set my own self because the population doesn't give.
Never mind, you don't have to. Do they plot the sustainable curve in the results in the paper? Did they
Oh,
plot? Huh?
paper. Yes. He did.
Okay, you can use. Okay, what?
Sustain-
Where's the infectious? I want sustainable. No, never. No, everywhere is going.
So I think the paper
Oh, they never.
doesn't.
Okay, but for infected people, it starts at around 200. The initial value is 200. Okay, recovered people, it starts for 0. That's the initial value. Okay, you must
Okay.
use that. And then is plotted against the years, wow, 5 years. So in your, okay, never mind. Okay, now you go back to the, so go to the one that has example, the recovered and the, what is it? What was it? Recovered and what? And
Recover
infectious.
and infectious.
Okay, you show me, open up the two. No, not E. E, I don't want. E, no use. We cannot compare.
Recover.
Recover is increasing, but why is it? And compare with theirs. Okay, recover is increasing, but why is it is taking a dip after some time? I think okay, recovered. Oh, U1. Oh, I think you see, ours is U1 is 0, they U1 is 0, the other two is okay. Okay. Because we have set our U1 0. See, our result is based on our input, which is not same like their input, because their input is telling us now U2 is 0. For them, they have U2 as 0. Yours is U1 is 0. Your result is based on U. Okay. Now, you understand what I'm saying, yeah? So,
Yeah. You mean in the code U values, right?
okay, in the code, you can set the, maybe you can set the U1. Go down. Where is the U1? Oh, yes, there. Okay, this U1, U2, maybe you go to your, never mind, not here. You go to your code, lah. You go to your code. Because there U2 is 0, is it? So wherever got U2, instead of U2, you can just simply try removing the U2 from the equation. Okay, just remove the U2 and run again. Okay, just like you're not giving U2 lah, and see whether the result now same like what in the paper. Okay, if because my thing is that are we getting the same result like the paper or not? With the without the U2? Okay, so now if it is same like paper, then we can assume that now with U1 your result seems to be better lah. But I'm not sure the result shown in the paper is based on the C1, C2, C3 they have mentioned, or did they change the weightage of the C1, C2, C3 for the outcome? Because I I don't see why C2 is vaccination, and I think I'm not sure. Maybe vaccination is too expensive or what. Okay, that's why it is not choosing the vaccination. But then in terms of weightage, it's like see, it makes sense in your work. The recovered to stay recovered forever because in the results of them, their results the vaccination is zero. That means you are not vaccinating, you're just treating like normal. Okay, that's why after after the second year it stopped, the recovered people start dropping. You understand why the recovered people start dropping is because
There's no
is there
vaccination.
no vaccination, they're getting reinfected. Okay, you understand?
Yes.
Okay, okay, so that's how lah. So you try you do and see whether you just try that lah. Okay, okay, anyway, good work.
Okay.
Good work,
All right.
Yeah. Thanks.
Right.
Anybody,
Thank
any
you,
more
sir.
questions? Okay, any more question, please? Anybody else? Anybody else, please? Anybody else, please? Anybody? Hey, not anybody. Most of you have not started, is it? I think only about 5, 6 have started, and they have some problem. They came to me. So far, I've helped two groups. I showed them some way. Okay, but please make sure your code is in a similar way that the examples that I give, not like don't give me the chat GPT's answers. Hello, anybody there? Looks like nobody is okay. Nobody is done means you have wait okay, if you wait let me open the past year question. Is next week the last class? Is it? Hello? Is next week the last class? Is next
I
week?
think this week is week 12.
Okay, that means we have 2 more weeks. Okay. Okay, now, okay, I think we still have time. The last week, I want you to present your, again, very simple, maybe three slides or what. I want you to present your your project, just 3 slides. Just I want to see the results. You just give me the model, the differentiation, objective, and the results. Results you plot the plot results, with and without. You plot the with and without in the same plot. That means with and without constraint in the same plot. Let's say output. Let's say you have a infected people with constraint and without constraint in the same plot, so that no need to do too many slides. Okay, I just want to see what's happening. Okay, can wherever possible, you think makes sense to combine them, then combine them. If it doesn't make sense to combine them, then don't combine them. Okay, can but the combination is between with and without constraint. Okay, okay. Now we go to the past year. Yeah. Okay, I'm not sure whether you can see my let me open, let me share my screen again. This is a past year paper. Okay, now I will share to you in WhatsApp. Okay, this is a past year paper. So then the questions, you just have to look at these questions for the PLC one. Yeah, very similar, but for the question 1 and 2, which is for optimal control, is not going to be same. Not going to be very similar. It's going to be quite different. Now, this case, look at this. I don't know whether I shared this before. Let me share the question first. KQC. Let me see. KQC 73703. Okay. Now this is the answer. Okay. You can open it in WhatsApp. And the other one is the answer. Let me give the answer. Okay. So what we do here is, I'm not sure this one is in your system or not. Probably it's already there in your what do you call system. So if you look at the first question, okay, let me share again. Stop sharing. Share the entire screen. Okay, now you look at the entire screen. Okay, now see X dot is first question. So they ask us to design the problem itself. Now the problem is okay, look at, so a 2D model of both moving and constant space is to be constructed based on x and y position, and constant velocity motion is given by v. U is the heading angle. So U is the input, U is the input. So we only control the angle. The fishing trip begins in an origin point and ends at final point after an unit of time. If that means we have the initial value and the final value for the x and y. So develop the boat speed in terms of x and y direction speed. So in this case, we will get the answer in terms of, okay, x dot is the velocity at the x and y is the velocity at y direction. So that is depending. We get v cos u and v sin u. How we got this? Well, if you look at the switch, okay. Now here, look here. So here is the boat. The boat is located something like this at the origin point. Okay, this is a boat put like that. Okay, this boat. So it has to go at certain angle. The angle is given by u. So at certain angle at u. Okay. For example, this is your u. Okay, u. So obviously, if it is going in the u direction, that means what? It's going on the u direction. So what is the unit? Let's say if I have something like this. Yeah, short. Okay, short. So u. So now u. This u. I have a angle. So you take the angle u, and then you do a trigonometry. This, which is the what is the this direction? What is this direction? Okay, what is this? Okay, this line. Okay, and what is this direction? So we are going in this direction, but at this is your direction of your x. Okay, so x dot, that means the speed at x dot is the speed at x direction. Okay, x is equals to what? Is equals to in terms of trigonometry is going to be what? Okay, you look at it. This x over this hypotenuse. Let's say hypotenuse, I call this as r. Okay, is equals to what? Is equals to what? Sine or cosine? Is sine, is it? Sine or cosine? Cosine, yes. So that is cos u. Okay. Okay. So now this hypotenuse is now we are referring to x dot. X dot. So I divide here. So down here is r dot. So r dot is the speed at this hypotenuse. The speed at the hypotenuse is actually v. So I can just say x dot is equals to r dot is equals to v. So therefore x dot divided by v is equals to cos u. So in other words, x dot is equals to v cos u. Okay, v cos u. Can I? So similar way you do for the y dot. Okay, but this question is a bit more challenging because they're asking you to come up with a model itself. Now, the question, next part of the question is they're asking if the more fish located at a higher value of y. That means the higher the value y, the more fish you can find. Therefore, you have to maximize the y. Okay, okay, maximize the y. So give me 1-2 minutes. I just have to settle something. Okay, I give you 1 minute or 2 minutes break first. Okay, sorry. Okay, we'll continue. Sorry about that. Now, coming back to the question. Okay, develop the we done already. Determine the objective function we done. That's maximizing the y.
We couldn't see your screen.
Okay, sorry. Sorry, but wait. Show share. I hope we can see the screen now. Is it possible? Yes. Okay. Now, determine the objective function. The second one, which I mentioned, okay, that is to maximize the y, because we are only going to do this optimization for unit of time, that's 0 to 1 only. Okay, next. Once you're done that, so you already have objective and you know the state variables x and y. Okay, now from there you develop your Hamiltonian. So your Hamiltonian is this, as you know, minus y, because it doesn't matter you put minus or positive, because this is when you minimize something negative, you get they're minimizing this y. Therefore they put a negative y there. So they call it maximum Podragin minimum principle. That's why they do that. But it doesn't matter. You can always put the plus y. It's just the choice of your DHDU. Okay, when it's maximization, you must use what input. Okay, now here h is equals to minus u y plus lambda v cos u for the x dot, and then lambda y dot you replace with v sin u. Okay, and then we find a DHDU since we already have the Hamiltonian equation, we derive it against the U to find and equate it to 0. Okay, so when you have this is not a linear H is not linear to U, so because the U is inside the trigonometry function cos and sine, so it's no more linear, so you can simply derive H against U and equate to 0. You will get another equation, because this 0 is equal to minus lambda x v sine u plus lambda y v cos u. This one now you will you can bring one to the left hand side and then solve it, and you get tangent u equals to lambda y over lambda x. Therefore, u is called arctangent of what lambda y over lambda x. Okay, the adjoint equation is the adjoint equation is what? Adjoint equation, you just derive, there are two variables, x and y, so you just derive h against x and h against y. Obviously, there's negative y in the Hamiltonian, so when you derive against y, you will get a value which is minus dh dy equals to 1, and therefore solving that is pretty straightforward. You will get a constant a2 plus t. Okay, can I? Okay, and then lambda x is just a constant. Okay, so therefore we know the lambda 1 lambda x y in terms of t, you just replace in the tangent u, so there's those values, and you will get in terms of a1 and a2, and you can because constant divide by constant is still another constant, so we can simply say c1 plus t, c1 plus c2 t is the equals to tangent u. Okay, can so that's very it's the most difficult part is the early part when you determine the x dot and y dot, which is the what do you call the state function, the state of the problem. The state of a problem you are defining. Okay, the question asks that. Okay, so that is for the first question. Now the second question, the second question is let me go to the question. Okay, second question. Okay. So by considering an optimal control system, this one, okay, x1 dot is because it is very common one, you have came across this many times. The aim is to have xdf equal 1 and t1 is equals to, my battery got some issues here. Let me, okay, now by considering an optimal control, okay, x1 dot is equals to u, where the x final value of the x must be 1, when at time equals to final time equals to 1. Okay, when u you can put only 1. So this is a function we want to minimize. I think this problem did I cover? I think this one I covered with you some time ago, is it? Okay. Now minimizing this function 3 plus u minus x, develop the Martian maximum principle. I think this one I have probably not. Oh, this is a very difficult problem also. Okay, now, okay, Hamiltonian is equal to 3 plus u minus x plus what is here? Lambda. Okay, maybe I put that p lah. P or p lambda u. Okay, lambda u. Okay, now, here they already got lambda. Okay, sorry, lambda. I put a lambda. Lambda. I put a p lah. Okay, so in this case, this is p dot. Okay, this is p dot. Sorry, p. No, not p dot. P dot. Is p. So I just put a p. Okay, now since we find dh dx, what's dh dx? In this case, dh dx in this case will be what? Only minus 1, because only x here. Is it? So we have dh dx equals to minus 1. Solving it, you get what? You're supposed to get answer here minus, I think should get minus t plus c. Okay, minus t plus c. Yeah. Okay. Now careful with the c, because the final value is given as, we can solve it until what is the c final value because the question problem already say final value of x is going to be 1. Okay, you can solve it also. Okay, can initial value is 0, and then this for x lah. So, but for lambda, okay, for lambda the final value is what? We don't know. Okay, sorry, for lambda we don't know what's the final value, because now the lambda final value is not 0, because your final value x is fixed. Your lambda final value is no more 0. It has to take some value, non-zero value. Okay, very difficult to determine that value, so we leave it as it is. We just put that c. Okay, now what is his du then? His du is you derive h against u. What do you get? You get 1 plus p. Okay, 1 plus p lah, because here p multiplied to u, so you get 1 plus p, the answer. Okay, and p, as you know, is equals to actually t minus t plus c. Okay, can so you can solve it in that way. This so in this case, it depends on the. It really depends on the c value. Depending on the c value, we can actually categorize the problem into so many ways. What happens? Okay, what happens when c is more than -1? We consider, and then c is less than 2. What is this meaning? Okay, basically, what's happening is that in case 1, yes, okay, we are only dealing with case 1, which is when TF is 1, XTF is equal to 1. So in this case, how do we get C is more than -1? Now, we just assume, okay, we just assume, because C, before that, we get this thing. Let me solve this first. For P, let's go back to the equation again. Let's try this again. So your H is going to be, I try right, start from scratch again. Let's not depend on the answer sheet. Answer sheet can be, okay, 3 plus u minus x. Okay, 3 plus x, 3 plus u minus x. 3 plus u minus x. Then you have to plus with lambda u. Okay, because your x dot is equals to u. Okay. Okay, now here you take dh dx, which is equals to negative lambda dot equals to -1. Okay, you'll get -1 for, because only here you derive h against x, you get -1. So that means lambda dot is equals to 1. Okay, lambda dot is equals to 1. Okay, lambda dot is equals to 1. So this one you solve it, what do you get? D lambda dt equals to 1. So you can bring this over here. If you integrate, you get lambda equals to t plus c. So it's correct lah. Okay, t plus c. That's the answer. Okay, now we know already t plus c is the answer. Now you go for dh du. So what was the equation again? Sorry, h was what? H was 3 plus u minus x plus lambda u. So your answer here is 1 plus lambda. And we know that your lambda is what? Hello? What is lambda? Just now we found 1 plus lambda is what's the answer we found just now for lambda? Hello? Lambda in terms of lambda is what? 1 plus? What was the answer for lambda just now? Lambda is equals to what? When you solve it, t plus c, isn't it? T plus c. So you put that lambda plus c. Okay? So this is your dh du. Okay? Can Don't follow the answer sheet. The answer sheet can be this is the dh du. So here, if this is more than 0 or less than 0, we can determine. Now, what happens if they have 4 conditions there here, and the answer sheet given as 4 conditions. Don't follow this. So you see here they straight away give what is u lah. U is 0.5 times then the referring to the sign of this. So that one you don't have to bother, right? Then you can simply say that 1 plus lambda plus c is more than 0 means what you must do, less than 0 what you must do. That's all. Okay. More than 0 what do you do? Less than more than 0, it is maximization, am I right? Or minimization. So refer to the problem again. This one is actually okay, this is minimization. So minimization means what we do, we take, okay, this more than 0 means you say u equals to u mean lah. Okay, in this case, u mean is what? U mean is 0, I think. Okay, and then you say when the 1 plus lambda plus c is less than 0, you say u is u max, which is 1. Okay, can I? Can I? So you, but what is, then again, what would be the c value? Okay, c value, okay, assuming okay. Now here there are 4 cases lah. I'm only showing for the first case. Okay. Now in the first case, why they saying that? Because it depends. We are more interested the XTF to get 1. That's why I'm showing in the first case. Okay. If XTF is 1, okay. Oh, okay. In this case, if C, this is what DHDU like. DHDU is what? T plus 1 plus C is more than 0. Okay. Okay. If you put X as, because the time is from maximum is what? Hello? Time is what? Maximum is what? Maximum time is 1. Okay. Maximum time is 1. Therefore, if this T, okay, if in this case C is more than -1, what does that mean? That means this T, let me put it this way. Oh, sorry. Okay, 1 plus T plus C is your DHDU. More than 0. Okay, less than 0. Okay, now here, if your C is more than or equal to -1, what does this mean? That means C is between 0, C is between 0, more than means anything more than 81, not necessarily less than 0. Can be anything more than 81. That means -1, -0.5, negative or 0 or 1 or whatever. So the moment this thing is more than, let's say I put here -1, what happened? That means T is what? T is, if more than 81, T is what? Hello? This T is what? More than or equal to 0. Correct? More than or equal to 0. Is it? Okay, there is T. Okay, for T, any value of T more than 0. Okay? Can I? If I put the C as at least -1, there's a most minimum. Those most minimum I can put. More than I can also put here -0.5. Okay. Okay. All that. So in this case, if I put -0.5 or 1 or what, then T is more than -2. Okay. Here, if you get C, which is more than or equals to -1, then we have T is more than or equal to 0. Now in this case, let's see. Okay, in this case, What does that mean? Of course, t is always going to be more than, t is always going to be, time is always going to be positive, isn't it? So for any value of t, your u is going to be u mean, which is 0. Okay? Can your u is going to be u mean. Okay? That means when u is u mean, u 0 means x dot is equals to 0. X dot is equal to 0. Since the initial value of x is 0, your x is going to remain 0 forever. Okay? So remember this, x is, if x is all the time 0, what happens? Will it achieve x at final time 1? No, it will never achieve because it's always 0. Okay, I hope you understand what I'm trying to say. Yeah, see, x dot was what? U, but now I set it 0. I set it to u mean, which is equal. Why I get u mean? Because if c is more than a -1, if I put here -1, c is -1, what happened? T is, of course, t is always going to be more than 0. Okay, t is always going to be more than 0. Okay, 0 or more than 0. For all that t more than 0 until whatever time, even to t equals to t final, which is equals to 1. Okay, what's going to happen is this equation always going to be more than 0. Correct? Because t is always going to take a positive value. Okay, t is always going to take a positive. Time is always positive region. Okay, so therefore, it's always, this thing always going to be, if this is -1, this is -1, c is -1. Okay, and if you take t, anything more than, anything more than let's say -0.5, what happens? So if minus, that means I get t more than equals to -0.5. Correct? Okay, that means t will what? This t is supposed to be all, not minus, from -0.5 to 0. It is not going, it doesn't make sense, isn't it? So t is always going to be anything more than what? Anything more than 0. But what does that mean? T is more than or equal to -0.5. That means from time 0 to 0.5, from time 0 to 0.5, your DHDU is going to be what? Your DHDU is going to be less than 0. You understand that? From time 0 to time, from t equals to 0, your DHDU. After that, your t can go more than 0. That means t going to take u max first and then become 0. Okay? Can So that's what it means, the c -1, or more than -1. Okay, but if you take, just now I say, in the worst case, -1, it will remain 0 forever. Okay, in the worst case, c -1 means, but anything more than that, yes, you can have x some value. Okay, and then become, so you do a test at what point. Now, if you set c must be more than or equals to 0.5, negative 0.5, or c is starting from -0.5, what happens? Okay, so that means I follow this lah. So DHDU, what you're going to get is, your u is going to be u max. That is, u is going to be where I plot u against time. Time is maximum until 1 only. So initial until final 0.5 is going to be u equals to 1. Okay, after that u is going to be 0. Okay, now what does that mean? Where did the XTF happen? So remember, your x is what? Your x dot is equal to u, and if u is until time 0.5, I see Lisa. If I put x dot equals to u equals to u max, which is 1, but the time is from 0 to 0.5. This is 0.5. Okay, 0.5. What happens? What happens? So I put there x is equals to t minus c is 0.5. I set it about 0.5. Okay, so your x, not t minus 0.5. So u is 1. See, x dot is equals to 1. So what's the solution for it? Solution for it is t plus c lah. Okay, plus c. Okay, and remember your c is going to be 0 because you are referring to x initial value 0, 1. X initial value was given in the problem as 0. Okay, so ax equals to. So when does does it mean x equals to at t 0.5, x is going to be what? 0.5. Okay, 0.5, huh? Because x is equal to t at time 0.5, x is going to be 0.5. See, okay, and then what happens? X becomes 0. U becomes 0. That means x is going to be remaining 0.5 until t. So this also cannot satisfy. Okay, so the only thing that can satisfy is when x remains, x becomes 1 and remains at u1 until the end. Is it? So therefore, your t now is, if x equals to t, then at t1, at t equals to tf equals to 1, your x is going to be 1. That satisfies the condition. Okay? So when is that x is equals to t? When u is remaining all the time. In other words, the c, this whole thing must, 1 plus t plus c must remain negative from time 1 to time 0. Okay? Time 1 to time 0. In other words, if I give here minus 2, does it make sense? If I give c as minus 2, what happens? Is it minus 2?
It will all
Yeah.
be negative.
Huh? What is that?
Always be negative.
Always
Negative.
negative 2. Always negative. So how to keep all negative? Your what will be your c value? Your c value must be, this one goes from time goes from 0 to 1. Okay, 0 to 1 time. So here 1 plus maximum is 1 plus minus 2. So c must be minus 2. Okay, minus 2 or less. Okay, minus 2 or less. Okay, your c must be minus 2 or less. That is your most logical answer for your problem. Okay, Tara? Okay, I think I'll stop here. This is a very because they're asking you to determine the C. Okay, in this case, C, which is the most logical C, makes sense C that you can find. That is, C must be less than. Don't follow the answer sheet. Answer sheet maybe not able to. You cannot interpret it easily. Okay, Kenna? Hello. Okay.
Okay.
Okay. Okay. You have any question on the assignment? Please, anybody right now you can ask me. If you don't have, we can call it a day.
Even
Yeah, tell me.
May I know how we pass up the assignment in the Spectrum? Because it only can upload one file.
Yeah, you combine all in one file. Your answer and your plot, everything, including your file, AMPL file. That one put in appendix, the last part. Okay, the AMPL file.
Okay, noted, sir.
Okay, but you must show the plot, plot with for two cases. One is without constraint, and then second part is the with constraint. Okay, yeah, and you also show the formulation. What is the formula you use, and what is the with constraint and without constraint? What's the formulation? Okay. Okay then.
Sir, can you show again the question one, the first part that you plotted?
This one.
Oh.
Okay.
So let's say if this the very first part we didn't get to the the costate equation, then the rest we cannot do already, is it?
Yeah. This one is very. This one you must determine first, lah. Then only you can come to the costate, all that. But this question not going to be repeated, lah. So we don't expect this question to come up. Okay. I'm not going in the coming exam. I'm not going to ask you to find out state the state equation. Okay, find out the state equation. No, that's not going to be a question like that anymore. Okay. Can I? So you have
Okay.
to straight the equations will be state equation will be given to you in the exam question. So you have to just find the DHDU and co-states and all that. Okay. Okay. Okay then. Okay, I'll stop here. See you. See you next. Yeah, tell me.
Exam. When is the final exam?
When is the final exam? Oh, actually, I also don't know. Now this is your 12th week, means this is the 12th next week. Another 2 more weeks, 2 more Sunday to go. After that, there's 1 week break for the study week. So 3 weeks. I expect another after 3 weeks from now.
26th of June.
26th of June. 26th of June is just 20 more days. Is it? 20 or 19 days to go. That's like the first weekend of the study week. Okay? So there's not much after. And that means next week is, today is 2nd, isn't it? Next week is 9. After that is what? 9 plus 7 is what? 16?
16,
Then the
23.
23 lah. 23 or 22nd?
26th of June is Wednesday, I think. Yeah, Wednesday.
What time?
What time? Whether 11:30 until 1:30.
Okay. Okay then. Okay then. Okay, thanks.
Thank you, Doctor.
Thanks, bye.
Thank you, Doctor.
Thanks, bye.